I'm recording you now, so you better be good. Law of sines is another way to solve triangles, to find the sides and the angles. Okay, and it's used for solving oblique. You know what oblique means?
I used to.
Oblique, that means non-right triangles. Not right, not wrong, but non-right triangles. Oblique triangles. When given a side angle, or an angle side angle, or even a side angle. But when you're given a side angle, which we'll talk about later, that's called we'll talk about that tomorrow. That's called the ambiguous case. So we're not going to talk about ambiguous case today. So today we're just going to look at triangles that are side angle or angle side angle. Okay? So, and I do kind of want to show you where law of sines comes from, because I think it's kind of cool, and maybe you'll appreciate it, maybe you won't. Oh, let's see if this tool works. Can I draw a triangle? Did that draw a triangle? Come on. Oh, it worked. Okay.
Did you get an updated one of these?
An updated what? Moby board?
Yeah,
It's got a touch screen one.
I got the really nice, the deluxe
I thought you
edition.
had that before break.
I did. No, it's not. Why am I doing really well? Thanks. Thanks. Okay.
Our new program.
You get an A.
With, like, the road
I've been
for the
practicing.
chicken.
I practiced over break.
And I did the
My Moby board.
I was
Okay.
on the radio.
So
And I said that he was okay.
I just want to show you law of sines where it comes from. Now you don't have to necessarily derive this on a test or anything, but it would be nice to know where it comes from. So if you take an oblique triangle and you look at two separate triangles, you know that the sine of B, and you draw a height or an altitude right down there. What's the sine of B equal to? Hello. Opposite over hypotenuse, which is what in this case? H over A. Okay. What's the sine of A equal to? H over B. And then if I do a little algebra here, I can solve, and I could get that A sine B equals H, and also B sine A equals H. And because this H must be equal to that H, then I can say that A sine of angle B, I substitute this in over here, I get that A sine B equals B sine A. And then if I divide both sides by both A and B, which I can do, I end up, these B's cancel out and these A's cancel out, right? And I get basically the law of sines, which says that sine of B over B is equal to sine of A over A. And if I extended that and turned my triangle sideways and did another height, I could show that that's also equal to sine of C over C. Okay? And that's basically where the law of sines comes from. You've seen that before, right?
I've never seen that before.
You've never seen the law of sines?
No, I've seen the law of sines, but not like the explanation.
But you didn't know where it came from.
Nah.
See?
I learned
You find
something.
you learn something. Okay, but that's basically where the law of sines, because you start with, you break a triangle into two right triangles, and then you can break it up like that, and that's where it comes from. So the sine of an opposite angle is equal to the sine of this angle over this side is equal to the sine of this angle over this side, which is equal to the sine of this angle over this side. So in order to show that it's true for C, you would have to draw another altitude going the other way, but you could do it. All right. And so, and in this case, you also know in your book, instead of calling these A, B, and C, they have to make things be complicated. So they call this beta, they call this alpha, and they call this, oh no, I hate drawing these things. They call this gamma, which looks kind of like that. Alpha, beta, and alpha, beta, gamma. Okay? And that's a lot. And what's true about these three things? What's true about beta plus alpha plus gamma? How much do they add up to? 180 degrees. So that's the second part of law of sines, is that these three things add up to 180. All right, so now we'll do an example problem. You want to do an example problem?
Sure.
Sure. Okay. So, and I only have 3 example problems for you today. Solve the triangle. And let's see. I have, let me see if I can use my cool tool again. No, I've just been practicing with this tool, Jeff, so I'm getting really good at it. Did it work?
That's pro.
Oh, isn't that Isn't that amazing? Okay. So say I'm told that this is 40. This is way off because this doesn't look like it's 40 and this doesn't look like it's 48, does it? Okay. So a lot of things, I'm doing this on purpose because a lot of times things are not drawn to scale. A, B, C, and then they call this, then this side is 5, and this side is B, and this side is C. Okay? So this is a case in which I have people, you kind of have to decide sometimes what I'm going to use, right? So in this case, since I have an angle, then a side, that means that I'm going to use law of sines. If you have an angle, side angle, you could also use law of sines, or a side angle, but anything else you're going to have to use law of cosines, which we'll talk about Monday.
Wait,
Okay?
now, I have a question.
Yes, sir.
You said it's angle, side, right?
Yes.
Do you just like always read the triangle left and right? Or whatever?
No, it's side angle is the same as angle side. Doesn't matter. So side angle side doesn't matter. Okay?
You sound like a bell.
Angle. Yeah, we come up with such unique outlooks on things. Very good. Okay, so now use a lot of signs. Sine of 40, it's just like a proportion. Sine of 40 is to 5, as sine of 48 is to B. Okay? And, right? And now what you probably want to do is cross multiply. You know how to cross multiply, right? And so you get, let's see, cross this times this. So you get B sine 40 equals 5 sine 48. Don't multiply the 5 times the 48. 5 is times sine of 48, right? Because it's sine of that. And then you divide both sides. It's kind of better to, you don't want to plug things into your calculator until the very end. So then you get B equals 5 sine of 48 divided by sine of 40. And then you take your calculator, which will be right there. It's, what's the answer? Let's see if that's right. 5 sine 48 close parentheses divided by sine of 40. Something here. Sine of 40, it just got bigger. Okay, and that is equal to 5.78. So side B is 5.78. So that's part of the solution. The other part of the solution is to find this angle right here, right? Which is, I don't have to do any law of sines or cosines or anything like that. I just need to add up to 180, right? So this will be 180 subtract 40 plus 48. Yes, because triangles add up to 180 and alpha plus beta plus gamma. So C has to be 180 minus 88, which is how much?
92.
Minus 88, which is 92 degrees. 92 degrees, right here. Even though it doesn't look like 92 degrees, but I drew it intentionally not to scale. What's wrong, Jay?
I think you did.
Never mind.
Yeah.
Okay, so now that I know this, I want to still find C. So you cannot use Pythagorean theorem because it's not a right triangle. If you knew law of cosines, you could use law of cosines to find C, but you might as well just use law of sines again. So I could say, so to find C, you say now you know sine of 92 is to C as, and what I would not do, I wouldn't say sine of 48 is to 5.78 because this is a rounded off answer. So I would use these two sides because you could use any, or that angle on that opposite side. So sine of 40 is to 5. So try not to use the one that's rounded off because you'll lose a little bit of accuracy. And then solving algebraically, I believe that you get that C is equal to 5 sine of 92. 5 sine of 92. 5 sine of 92 divided by, did I do that right? 5, yeah. Sine of 40. Okay. And if you do that on your calculator, you get that that's about 7.77, right? You go. You're right on top of it. 7.77 or something. So that's how you solve a triangle. Any questions about that? Do you need a little comic relief?
Yeah.
All right. I can't because I'm not being recorded. Okay, we're unpausing, we're recording it. So we're moving on to a case in which you want to, into a problem where you have a angle, side angle case. Okay, so I'm going to try to draw another triangle with my my cool tool here. That kind of looks kind of over like, oh, is that a nice thing? Okay. So then I'm going to call this angle, let's do it in green, I'm getting tired of it. 35 degrees, okay? And 15 degrees, and this over here is 5. And then they want you to find, well, this isn't one where you have to find an angle, is it? Oh, finding angles, that's reserved for side-side angle. So we're not going to find an angle, right? I mean, this angle is easy to find, right?
Yeah.
And so say I want to find, so this is a case in which you have an angle, side angle, and you could easily find this side, which is 180 minus, what's that, 35 and 15 minus 50, which gives you 130 degrees, right? And now you can, so I'm not going to do both sides, so let's just do this side over here. We'll call it B.
Could you turn it into like a right triangle and to find the side of 15 degrees, like A?
Right, make this a right triangle right here.
I was thinking of making the other one a right
Straight
triangle.
down?
Yeah, same thing.
Yeah, I guess you could, but
No, like not straight down, like straight down, but from the 130 degree angle straight up to find the.
like this.
No, up straight.
So straight up.
Like
Yeah.
that. And then you could just like use
Not really, because then it wouldn't be a right triangle, right?
well, but you could use like the cosine of 35 to find that one side.
Yeah, but then you'd have to do another step. And it wouldn't be a right triangle if it was going straight up from here. It wouldn't be a right triangle. Okay, so, no, you can't do it. Okay, anyway. So, well, let's just do it. Sine of 130 is to 5, as sine of 35 is to B. And then you just do the same thing you did before. So you get B is equal to 5 sine. I'm not going to do the 2 steps, I'm just going fast. 5 sine of 35 over sine of 130. When you solve for b, that's what you get. And then you plug that into your calculator, and you get that b is 3.74. Is that right, Alana? Is that what you got? 3.74. And if you want to find this side over here, I'm not going to do it, but A comes out to be 1.69. Okay? So that's how you find it when it's angle side angle. So if it's an angle side angle, first you have to find this other angle by adding them up to 180 and then subtracting from 180, and then you can do sines. Okay? Now the next thing we're going to talk about is a bearing problem. Oh! That reminds me. When I was riding my skateboard the other day, I had some bearing problems. When I was riding my skateboard the other day, I had some bearing problems.
When I married a bear, I had a bearing problem. Or when I was trying to.
When I was riding my skateboard the other day, I had some bearing problems.
You wrote a sign that said for us to laugh.
When I was trying to propose.
I
Okay.
can't wait to watch it. Actually, wait, I'm not watching this one. I'm watching the other one.
So we're going to do this.
Just the soundtrack of this with no picture to see what's going on in the class and everything.
So here we have a bearing problem. Coast Guard. I changed the words to make it more interesting. I don't know how I hide this toolbar. How do you hide these toolbars? You guys know how to hide these toolbars?
The arrow next to the question mark at the top, to the right.
This?
Yeah. I'm pretty sure. Yeah.
Oh, nice. Thank you. Okay. So Coast Guard Station Monarch is located 120 mile due west of Station. Who's that? Centaurus. A ship at sea sends an SOS call that is received by each station. The station Monarch indicates that the bearing of the ship from Monarch is north 40 degrees east. Centaurus indicates that the bearing of the ship from Centaurus is north 30 degrees west. How far is the ship from the station? And then if a helicopter can fly at 200 miles an hour from the air station, how long will it take to reach the ship? So this is an application of
40 miles away from the mall.
well, we're just playing here, okay? So so the way you would want to do this is draw a picture of 120 miles due west. So first I better get my tools back here. So first I'm gonna draw a straight line here. So wait. What happened to my, where did it go? Oh, it's down here? There it is, okay? So the first thing I'm going to do is draw a, why is it?
Take a picture.
There we go. So, take a picture of it so that you can see what's going on. Yeah, that's what I'm going to do. Okay, so let's.
Drink real quick.
Okay. So I'm gonna place this capture new page. So here we go. And so I'm gonna make this a little smaller. You don't need that big. All right. So now I'm gonna draw a picture, and I'm gonna go like this. And due west of Station Monarch is due west. So this would be due west, right? So we're gonna call Monarch is over here, and Centaurus is over here, and then located 1 mile. So this is 120 miles, Okay? And the hard part of this is just figuring out how to draw. A ship at sea sends an SOS call that's received by each station. The station Monarch arc indicates that the ship from Monarch is north 40 degrees east. So what that means is if I were to draw a line straight up this way.
Is it Monarch west or Centaurus?
Yeah, I don't know. We're just making stuff up. Okay. So if this is north, okay, then north 40 degrees east would be 40 degrees east of north, right? Okay. So in other words, this angle right here is 40 degrees. Okay. And from Centaurus indicates that the bearing of the ship from Centaurus is north 30 degrees west. So in other words, if I were to draw a line straight up here, it's 30 degrees west of north. So going this way. Okay, you get that? And so this angle here is 30 degrees. And where they meet, right here, that's where the ship is. There's the ship. Okay? And so, there's that portholes. There's the ship. Okay? And so then all you have to do is, it says, the question was figure out which one it's closer to. Is that right? Is that what it said? Which one is it closer to? So if this is 40 degrees, what would this angle have to be right here? 50. And if this is 30 degrees, then this has to be 60. Okay? And then you want to find each of these things. Well, before I could do that, this is angle, side angle. First I found out this angle. What's that angle got to be?
70.
You understand why that's 70? Because those have to add to 180. So this up here has got to be 110 subtract from 180. So that's got to be 70 degrees up there. So then I could say that we'll call this A and we'll call this B. Okay? So sine of 70 is to A as sine of 6.
Sine of 70.
Whoops, sine of 70, thanks, John. Sine of 70 is to 120, right? As sine of 50 is to A. And then you just do the same thing we've been doing. A is equal to 120 sine 50 divided by sine 70. And if I do that on my calculator, I get that A is 97.8 about miles. Okay. And then you do the same thing to find B. I'm not going to do all the math. And you get that B is about 110.59 miles. Doing the same thing, so you say sine of 60 is to B, sine of 70 is to 120. And so you would get B is 110.59. And what was the question? Again, now we have to go. Now, who is closest? It looks like, oh, I should have made these guys Monarch,
How long
right?
would it take if it was?
Yeah, oh,
200
how long would it take
helicopter?
if the helicopter? So it looks like these guys are closest, right? So it would, so Centaurus is closer, and yeah, if the helicopter flies at 200 miles an hour, how long would it take? So it's 200. Well, you want to go. You want to do it 200 miles an hour divided by 97.8 miles, right? So 200 divided by 97.8, because they're the closer ones, gives you 200 divided by 97.8 equals 2.044 hours. 2.044 hours, or about 2 hours and 0.044 times 60.
I think
It
the other way around.
If you go 200 miles an hour, you're going to go well past it in 1 hour.
Yeah, then you flip this.
No, you're gonna go.
Oh,
back
shoot,
like half
you're
an hour.
wrong. I'm right.
Did the mile
Okay,
on top.
so what I should have done, now I have to re-record my video.
Okay, you're gonna go through
Okay.
it in about half an hour.
You're right. Sorry. I should have looked at my notes. I
Oh
wasn't looking.
man.
Okay, so you're going 200 miles per hour. So in 1 hour, I'm going to do it with units converted. In 1 hour, you're going 200 miles, right? And so you want to know how many hours. So how long will it take to go 97.8 miles? There we go. Okay, so the miles will cancel out and you'll get hours. So if I do, let's do this right this time. 97.8 divided by 200 equals 0.489 miles, 0.489 hours. And if I multiply that by 60, right, times 60, because I want to know in minutes, that'd be about 29.34 minutes is how long it will take. So can you say the Titanic? I don't know. Okay, and your homework is, oh, you don't have an assignment sheet, do you?
No.
Page five, you don't have, it's not on there. 538, 1 through 5, 7, 9,
What the heck?
10, 23, 37, 39, 42, and 57. That's all. That's it. Okay? And that's not bad. And that's the end. Now I can stop my video.